Okay, algebra students, hello again. So video number 2, we got this function right here, which is f of x equals, it was 2 to the power of, what was it? Sorry, 2 to the power of x plus 1, and then minus 4. We took that, and we converted this, and we found the inverse of this. The inverse of an exponential is a log. So we had done all that, and so, we ended up getting this. Then I said, you have to watch video 2 for that, how we did that. Then I said, you know what? Let's graph a log now. Okay, so now that was the inverse. Now we're going to graph this function. I'm going to do it as g of x. Doesn't matter. Just the last graph we had done f of x. I'm just going to do this like, let's just pretend you get a function like this, and it says graph. Okay, same thing. Same thing. We just made a g of x. That's all. Okay, let's graph this function. Again, like always, as always, we are going to do a cute little t-table, but, very important that we use some smart values. You don't just want to put any number here because it's going to make it a little bit confusing, okay? Before we do anything here, okay, so let's try this. We are going to do this little section right here first, okay? And then whatever we get, we'll do minus 1. All right, I'm going to plug in a 0 first. 0. That'll give me log base 2 of 4. Now, log base 2 of 4, what is that? Look at this. Log base 2 of 4, just want you to understand the idea. If I convert that to exponential, that means 2 to the power of what? 2 to the power of x, so the power of what is equal to 4? 2 to the power of what is equal to 4? Well, I'm asking you, what do you think? 2 to the power of what is equal to 4? Clearly 2 to the power of 2. This entire thing is just 2. Got it. This is 2. When I plug in 0 here, I get log base 2 of 4. Log base 2 of 4 is just 2. And then at the end, we have to do what? Minus 1. 2 minus 1 is 1. Okay. I'm just plugging in some points here. Now, something else that wouldn't be. Let me tell you something. When I say smart values, what I mean by smart values. If I were to try 1, look what happens. I would get log base 2. If I plug in a 1 here, I get a 5. So let me ask you this question. Log base 2 of 5 basically means this. 2 to the power of what would equal to 5? I'm sorry, sir. 2 to the power of, something, 2 point something. I'm not a calculator. I don't know 2 to the power of something that equals 5. It's not a whole number. It's a decimal. So I'm not going to plug in 1. Clearly, that's not a fun answer. So what can I plug in? That's the interesting question. What can I plug in? First, let me do 0, 1. Okay. What can I plug in? Well, I'm going to plug in, believe it or not, I'm going to plug in 4. And you'll see why I do that. If I plug in 4, I get this. Log base 2 of 4 plus 4 is 8. And all of this minus 1. That means 2 to the power of what is equal to 8? 2 to the power of something is equal to 8. That is going to be 3. Yeah, it clearly is 3. So log base 2 of 8, the whole thing is just 3. 3 minus 1 is 2. 3 minus 1 is 2. So we have 4 comma 2. 4 comma 2. Absolutely wonderful. Cool. Okay. I do want to save you a little bit of time right now, though. I do want to save you a little bit of time. Okay. What is going to happen here? Now, keep in mind here that if I told you guys, hey, you guys, 2 to the power of what is equal to 0? Think about this for a second. 2 to the power of what is equal to 0? Nothing. Absolutely nothing. 2 to the power of nothing is 0. 2 to the power of 1 is 2. 2 to the power of 0 is 1. 2 to the power of nothing is 0. So what I'm basically telling you is this, okay? If I were to, let's say I move this, well, I'm going to keep it like that. Let's say I'm looking at this, and I ask you guys, hey, let's make this a 0. Let me make that a 0. And I can make it a 0 by doing -4. I'll make x -4. Now look carefully at what happens here. If I try to plug in -4, look at what happens. If I make that -4, I get log base 2 of -4 plus 4 is 0. Uh-oh. Uh-oh. We're going to have an error here. Here's why. If I do that, I will get, that means 2 to the power of what is equal to 0? It doesn't. 2 to the power of nothing is equal to 0. We get what's called an asymptote. So what's our asymptote? Right there. X is -4. That's our asymptote. So we're going to go to -4 on the x. We're going to go to -4 on the x and draw an asymptote. Draw an asymptote. Okay, you don't believe me? Here, try this. What if I told you guys log base 10 of 0? That means 10 to the power of what is equal to 0? Nothing is. 10 to the power of nothing is 0. You don't believe me? Do this. On your calculator, you don't write down log base 10. They just say log. When they just put log, like log of 0, that just means log base 10 of 0. It's the invisible 10, right? Go to your calculator and do log of 0. Let's see what the calculator says. Log of 0. It won't give it to you. It might say domain error or something like that. It won't have it. You can't have a log of 0 because 10 to the power of nothing is equal to 0. We just found our asymptote. Now, if you remember, in exponential, our asymptote was a horizontal asymptote, went left to right. This time we have what's called a vertical asymptote. On logs, we have vertical asymptotes. So the asymptote is at x equals -4. That's our asymptote. I'm going to make this a lot easier for you guys now. Okay, remember, in an exponential, we had our asymptote. Our exponential graph came like that, and it was riding along the asymptote, but it never actually touched the asymptote, right? Same thing's going to happen here, but if you notice, this graph is going like that. So what is this going to look like? It's going to come down this way and go like, now I haven't done all these minor points to tell you exactly where it's going to be at. It's going to be something like that. It's going to come down like this and right along that asymptote. Okay. So to give you another example here, of graphing, just so we can erase this. Okay, so I got x equals -4 because that made this a log base 2 of 0, which we cannot have. So I'm going to do another problem just like this. Okay. Let's make this log base 3 of x minus 2, and we'll do minus 3. Okay. I'm going to do the fastest way I could possibly graph this, okay? The asymptote, this cannot be 0, because we cannot have log base 3 of 0. To make that 0, x would have to be, I'm going to go to x equals 2. Now I'm going to ask myself, well, what's the x and y intercept? Okay, so we got that. I just want to ask myself, what's the x and y intercept? Let's do x intercept. And I'll do y-intercept. Because I don't know which way this is going right now. It looks confusing. X-intercept, y equals 0. Let's do it. X-intercept, y equals 0. I will, let's do this real quickly over here. Okay, I'm going to move that 3. So I'm going to do plus 3. Plus 3 here. Log form, I'm going to convert it to exponential. Basically, that means 3 to the power of 3. 3 to the power of 3 equals x minus 2. 3 to the power of 3 is 27. Plus 2, 29. The x-intercept is all the way to 29. It's going to be something like that. All the way there at 29. I can't reach it. Let's try y-intercept. Now, I'm curious about something. Before I even do y-intercept, I'm curious about something. If my asymptote is here, I'm basically saying this exponential graph is going to come like this. I'm sorry, this logarithmic graph is going to come like this, and it's going to stop. It's going to get really close to the asymptote, it's going to stop. But wait a minute. if I have a y-intercept, the y-intercept's got to touch the y-axis. This is the y-axis. But wait a minute, the asymptote is that way. How the hell is it going to touch the y-axis if logarithmic function comes this way? It never actually gets to the y-axis. I'm curious what's going to happen. Let's try it. Let's try to find the y-intercept. Okay, let's try to find the y-intercept. To get the y-intercept, we make the x 0. Okay, so then that's going to give us f of x equals log base 3 of 0 minus 2 is negative 2 minus 3. I'm going to stop right there, and I'm going to convert this to exponential. Ready? Log base 3 of negative 2 means 3 to the power of what equals negative 2? I'll wait. 3 to the power of what? 3 to the power of anything going to equal negative? No, it's not. 3 to the power of nothing is going to equal negative. It's just not going to happen. If I say, oh, 10 to the power of what equals negative 100? Oh, I know, 2. No, 10 to the power of 2 is 100. Negative 2. No, 10 to the power of negative 2 is 1 over 100. It's not negative 100. So you can't get a negative answer like that. Okay, 3 to the power of nothing is negative. Just like 3 to the power of nothing is 0, 3 to the power of nothing is negative. So guess what? This cannot happen. So y-intercept, when you make your x 0, you can't get it. There is no y-intercept. Why is there no y-intercept? Because obviously this graph does never even touch the y. Okay, so this is what an exponential graph looks like. All right, we take this right here, it's the opposite of that. So the opposite of that, and our asymptote is going to be right there. So opposite of negative 2 is 2. That's our asymptote. You draw your asymptote, try to get an x and y intercept, and you draw. So if you look at it, it's similar to an exponential graph, but it's just kind of flipped on its side because now the asymptote is a vertical asymptote, not a horizontal asymptote. This is video 3, and you are going to see one last video.